Ma'am, you're not audible.
Oh, I was unmute. Sorry, I was muted, right?
Yes, ma'am.
Also, whatever I said, you guys didn't hear anything.
No, ma'am.
Okay. Sorry. Okay, so let me start from the beginning. Okay, so what I'm writing here, Y1, Y2, Y3 till YN, is actually the claim amounts for the reinsurance company. Okay, and now what I want to do is, based on my past data, I'm trying to see what distribution I can fit. So once I decide on my distribution, once I know what is my f of x here, what I will do now is I want to figure out what are the parameters of this distribution. So again, the parameter value that it takes, that is what we are concerning ourselves now with. So we have to determine the optimal parameters for this distribution that we think fits best to the data that we have at hand. So as to have some information about the aggregate data set and then leverage that information to gather some more information about the unknown future and make our decisions based on that analysis. So if I were to talk about the reinsurance guide, for the reinsurance guide, these are the claim amounts incurred by the reinsurance company. So they know each and every claim amount that they have to incur. So be it Y1, Y2, Y3, YN. So this is just the notation for the claim amounts incurred by those. So these are the values that the random variable Y will take. Again, I think I should be saying Z here because that is how we generally denote the reinsurance. But I guess you guys get the gist of it. Okay, so now what I have to do is I have to use my maximum likelihood estimation method to figure out a way to just determine my optimal parameters that will make what I have observed the most likely to be observed, right? And again, you can also use method of moments as well as the method of percentiles, but sometimes it's just not possible to use them because either the detention level is higher or sometimes the moments do not exist. So you cannot calculate the moments, or sometimes the moments do not capture the essence of the distribution. Maybe because it doesn't have a heavier tail than what we expect. And yeah, these could be just couple of reasons of why we have to go with maximum likelihood estimation. Because again, for one thing, so if we have a look at the insurance companies claim amounts, what happens is we only know for the insurance company that it will be X1, then it will be X2. But again, for some of the cases, we do get only M as the amount, right? Which is actually incurred by the insurance company. So what's happening is you do not know the actual amount of the claim. You only know the claim amount which you have to incur, which you have to deal with. So you don't know whether this amount was M plus 1 or M plus 1000. It could have been anything, but you only know the fact that this amount is M at least, right? Because that is the only reason why you would have M here, and the rest of the amount is paid by the reinsurance company. So let's say if it is M plus 1, reinsurance company would know that they have paid 1, reinsurance company would know that they have paid 1000. So they would know that, the actual claim was M plus 1000, M plus 1, and so on. So for these guys, the likelihood function will be easy. You just have to multiply all of this together. I mean, the likelihood of occurrence of all of these together. Because again, why can we multiply them together? Because we're assuming that all of these claim amounts occur independently of each another, and that allows us to multiply them together. So now we all have to wonder, what can we do if we have such a data set? So we know that X1 has occurred for sure, but for these M things, we don't know what was the actual claim amount. So these kind of samples are known as censored samples, where some sort of information is censored. You don't know the all of it, but you know some of it. So that's good. So again, what you do is you divide your maximum likelihood into two parts. And let us say we are assuming that n of these values. So I'm denoting here my x denotes the claim amounts for an insurance company. Okay. So what I am saying is that n number of claims out of the total n number of claims are the kind of claims where I have recorded exactly what was the claim amount, right? So ignoring the fact that you even incurred some another claims apart from this n, if I were to just write the likelihood function for these guys, it would be something like this, right? Your pi goes from 1 till n, f of xi theta, right? Do you guys agree? So here theta, I'm just assuming that is some parameter of the distribution that I'm trying to fit. So let's say if you're trying to fit normal, which you generally should not, you would have mu and sigma over there. And if you're using gamma or something, you'll have its parameters. If you're using Pareto, you will again have alpha, lambda, and so on. So, okay. So does this make sense?
Yes, ma'am.
Yeah. So now this will remain as it is. So first part of our MLE remains as it is. But again, we also have to take into consideration the M number of, so the smaller number of claims. So what I'm saying here is that I have small m is my number of claims I incur loss of M, capital M. Right. So these will be the number of cases wherein we have to involve the reinsurance company. And again, I guess the very first thing that comes to mind, if I were to write a likelihood of these guys, would be what? Can you guys guess? So just don't look at what's there in the book. Try to guess. If I say you the information that I am paying a claim amount of capital N, then what should be my likelihood function? So again, if I'm writing my second likelihood based on a parameter which is theta, again, I'll just have pi, I going from 1 to small m, because these are the number of claims I have for the loss of capital M. So what do you guys think I should write here? Anyone? What should I write there? Yes? Anyone? Come on. What do you guys think can be the likelihood there?
Only for the claims with value greater than M, right?
Why do you think it should be greater than M?
No, I'm asking the likelihood of that only, right?
As in,
As in, like the first one was for the X amounts that is lesser than the retention limit.
yeah,
So now here we are considering the likelihood of the amounts greater than the retention limit, right?
but I am paying M amount, right? So what I will look at is the fact that X is equal to M, right? Why do I have to look at the fact that X is greater than M? Why can't I write that, probability that X is equal to M because I'm paying only M, right? I don't pay greater than M. Why would I care about that?
Because that wouldn't be right. Like, we need an idea
Why?
of the actual claim amount, right? Not only what we are paying.
Exactly right. So what we are looking at is the likelihood that I will have to pay M, and that is not exactly probability that X equal to M, because that is just one of the possibilities where I pay M amount, and there are certain other possibilities as well wherein I have to pay the claim amount M. So I have to take into consideration the probability that X is greater than M as well, right? Because if that happens, then also I am paying M amount. Give me a second, guys. Hello. 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 Am I audible?
Yes, ma'am.
Yeah. So I guess the internet went off for a while, so I lost what I was writing. But again, you guys now, do you guys understand why do we have to take into account the probability of X being greater than M? Even though we are only incurring a loss of amount M, right? So Now what happens is we have this excess n times and we have this m, capital m times, small m times, okay? So again, this is my second likelihood function, this is my first likelihood function. I mean, not exactly these two are separate, but again, I can actually say that this is a function and this is another function, right? Because this is a function of these claims and this is a function of these claims. So now if I were to write the complete likelihood function, it would just be a multiplication of L1 times L2, right? Because again, I'm assuming that each of these claims are independent of each other. And that is what you have to assume always. Otherwise, these things you cannot multiply together. And you will have to take into account the joint probability. But again, here, you only take into account the marginal probabilities precisely because you can ignore the fact that a claim incurring might imply something else about the another claim incurring or not incurring. So again, what they have done here is they have rewritten the probability of x being greater than m as 1 minus the probability that x will be less than m, and this can just be f of m, right? And that is what they have done here. So 1 minus f of m will just be another constant, right? So again, what happened here was for each x's, this f's value will differ. But if I have a m here, I know that this is one constant and it does not change with my change in i's, or if I let's say take this or this, it really doesn't matter. The chance that this is going to happen is the same. And that is why this is just a constant. So when I'm multiplying any constant and m times, small m times, what I can do is I can just make it to the power of small m, right? Does this make sense? Can you all hear me?
Yes, ma'am.
Yeah, right. So does this make sense? Do you guys
Yes.
see how we get the likelihood function? Okay, so I think I just quickly take us through one example of the likelihood function here. So, okay, let us try to devise our likelihood function. And I think that is the only part that we have to concern ourselves with. The rest of it is just solving like any other likelihood function. So you won't have to, like really use, I mean, okay, let me not say that. So, okay, just let us start with the question that we have. So, can someone read this question out for me? Anyone? Savri, would you like to read the question for me?
Okay, ma'am. Claims from a portfolio are believed to follow an exponential distribution. The insurer has effected individual excess of loss insurance with a retention limit of 1,000. The insurer observes a random sample of 100 claims and finds that the average amount of the 90 claims that do not exceed 1,000 is 82.9. There are 10 claims that do not exceed the retention limit. Calculate the maximum likelihood estimate of the parameter lambda.
So there are 10 claims that do exceed the retention limit, right? Okay. So let us try to summarize the information that we have in the question. And I would give each one of you a chance to do that. You know, like it happens in the Master Chef in the blindfold round, they'll give you a dish and you have to determine one of the ingredients. The same thing let's do here. So we have a question and we know that, even before we start the answer to this question, we have to summarize what's given and what is being asked for in the question itself. So we'll go turn by turn. And Isha, can you tell me one bit of information that I should be writing? What should be
So,
my, yeah.
if we are to form the likelihood function, so should I tell the first part like we had the L1 and L2 right now?
Forget about the likelihood function. I'm just talking about the ingredients of this question right now. Okay, so I just need to know what do you guys understand from this question. So again, this is like a word problem, right? And I want to write equations to summarize this thing. So let me start. So if I read the first line, I see that claims from a portfolio are believed to follow an exponential lambda. Again, I'm not given here. How do I define my claims? So let me define my claims by x. And I know that my x then follow exponential with lambda as the parameter. So this is one bit of ingredient from the question itself. Now, what does the other bit of question says?
So we have in the next line, they have told us about the retention limit that is 1000. So our M is equal to 1000.
Right, RM is equal to 1000. Vanshita, can you give me the next set of information?
Yeah, just a minute.
Yeah.
So it is given that the average amount of 90 claims that do not exceed 1000. That means the claims that do not exceed the retention limit, which comes under the first part, which is paid by the insurance company. So the average value, that is the expected value for that part, is 82.9.
Yeah, so how should I write it in terms of math and not words?
Would be something E of x or E of y is equal to 82.9. But not exactly.
Right, not exactly. Think about it.
Yeah.
What do Ishan Sauri think about it?
Uh, X bar will be 82.9, and we have given from the information we can see that N will be 90 and small m will be 10.
So, what did you say? N will be
N will be 90,
good.
uh, small m will be 10,
Yes.
and the 82.9 will be X bar. That is the mean for the first part of the likelihood.
The first part, right? So can I say that it is X bar?
Also, the n is total number. And the total over here is 100, right?
Yeah, so 100 is the total. And what I have written here is small n is just the number of claims where we do not involve the insurer company. So it will be just 100 minus 10, where we do involve the reinsurance company, right? So for n of these values, which is 90, we know the exact claim amount. But for these 10 claim amounts, we do not know the exact claim amount. We only know that there was a claim amount of M or greater than M. Does this make sense? So what does this line says? What does it say?
I think what Savri said would be right because this is like the X bar only, but just the uh, the number of claims that we are considering will be 90 instead of the whole sample.
Yeah. Okay, that does make sense. So again, if I were now to write the likelihood function and try to figure out basically the optimal estimator for my parameter lambda using MLE, what should be my next step?
So again, we will break it into two parts. So we will write L is equal to, or do we have to write the details also? L into bracket f
Yeah,
semicolon theta or lambda. Lambda
yeah,
is
it's fine if you just write the parameter as well.
okay. Is equal to pi, capital pi. I is equal to 1 to 90.
Yes.
Uh,
Now, can you explain the meaning of that line again? I mean, I got it theoretically, but it
The
wasn't
meaning
clear
of
mathematically. The line that you have highlighted.
the line that I have highlighted. Okay, so it is just saying that, the average amount of the 90 claims. So if we think about what could be these 90 claims, these are the 90 claims where reinsurer does not get involved, right? So that is why they do not exceed 1000 is 82.9. So this is just some information that we may or may not use. But again, we'll
Okay.
see of where. Just give me a minute. Yes. Okay, so what we are, okay, so what we have right now is the 90 number of claims that do not exceed 1000. We know that its mean is 82.9. So if I write instead of my x bar, so x bar would include what? X bar would include x1 plus x2 up until xn. So these are the amounts incurred by the insurance company only, right? And now what I'm doing is I'm adding again, let's say again n plus 1 till xn plus small m. And this will be upon small n plus small m, right? That is how I denote my x bar. Do you guys agree with this?
Yes, like for the whole
Right?
thing.
Yeah, so that is how I will write my whole of x bar. But again, remember what I have highlighted here in red is asking only for the 90 claims. So it's asking only for this n claims which do not exceed 1000. So what I can write is that 82.9 is equal to x1 plus x2 up until x90 upon 90, right? It ideally won't be X bar, but again, it is just a matter of denotation. If you say that X bar is defined in such a way, then this is true. But again, that will just be a confusing notation because X represents all of the claim amounts, not only a certain part of the claim amount which the insurance company pays. Only the insurance company pays. Does this make sense? Anshita, Nisha, Savri, do you guys understand it now? Better, meaning?
yes, ma'am.
Yes, ma'am.
Vanshita?
Yes, yes.
Okay, cool. So this is the information that we have with us now. Let me just see if I can move this across. Maybe not. Okay. So now we are to write its likelihood function. Let us continue with that. So again, who was dictating me about this? Go on. Getting record.
Ma'am, I'm confused now.
Where are you getting confused?
Because we have the x bar value, so not understanding what to do with that. Usually we have a function, right?
So see again, ignore the information that you don't need as of now, right? Because sometimes you don't even know when the information might come handy, or maybe it's just an extra bit of information that you don't need, right? So just see to it, what will you do if you want to write a likelihood function for this thing,
Oh, sorry, yeah, we know the distribution, so we can go ahead with that.
right? So what should I be doing next?
Just a minute. Yeah, so it is an exponential distribution. So after the pi, we will write
Hmm.
lambda
Okay.
into e to the power
Hmm.
minus lambda xi.
Right. And then?
And then into,
Hmm.
wait, will it be into or will it be plus? Yeah, into, right?
Take the opinion of your classmates. What does Savri and Vanshita think? Should it be plus or multiplication?
Multiplication.
Yeah,
Multiplication, right?
multiplication. Yeah.
Yeah. So what should I
So
multiply this with?
into pi, I is equal to 1. No, this will be 91 to 100, or will it be 1 to 10?
Anything you say. So again, if you write if
It doesn't
it
have an
depends on,
order, right?
see, it doesn't have an order, but again, if you are writing I, you have already taken 1 to 90 into consideration. So if you
Yeah,
write 91 to
91 to
100
100.
here, it's correct. But if you are writing 1 to 10, then you should probably take a J here or a K here, right? Not I.
Mm-hmm. Yeah, okay.
So yeah, it's fine if I write it 91 to 100 here. Then,
Yeah, so then it will be probability x
hmm,
greater than m, which over here is 1000.
yeah. So now I'm just looking at the probability that I get a value of x greater than 1000, right? Okay. So can I write that as a function like the one I did here? Vanshita, can you tell me what should be this in terms of lambda, e, and x is?
1 minus e raised to minus lambda xi. Hello.
Yeah. How should I
Was
write
I
it?
audible?
Yeah, yeah. I think I lost you because I was maybe muted. So again,
Okay.
if
1
I'm writing
minus
the, yeah,
e raised to minus lambda x. But here we have xi, so xi.
okay, so I'm only looking for this probability where my x follows exponential with lambda. Okay, forget about this part. I'm just looking for this probability here. Can you tell me what will it be?
Ma'am, it will be e raised to minus 1000 lambda.
Who was that?
Sabri ma'am.
Okay, but I want the answer from Vanshita. What do you think, Vanshita?
Yes, yes, I was going to say the same thing.
Wait, can you speak a bit louder so that I can hear you well?
Yeah, I was thinking the same thing.
What's that same thing? Can you dictate?
1 minus e raised to minus 1000 lambda.
So you think this should be the answer?
Yeah.
How did you come up with this answer? Can I know?
Yeah, because we are considering x greater than 1000. So,
Yeah. So,
it's f of 1000. So we substitute x is equal to 1000 in the formula of f of x, capital of x.
so you think it is f of 1000? Do you guys agree, Isha and Sabri, with what she just said? So again, Vanshita,
It's
tell
minus.
me.
It's e raised to minus 1000 lambda, sorry.
Yeah, right. Because f of
Yeah,
1000 is what? Its
is
probability that my x takes a
less
value
than.
less than 1000. So this will be 1 minus. So 1 minus of this thing, and everything else will cancel out and will be left only with, according to what we have on the board, we'll be left with this, right?
Yes.
Does this make sense? Okay. So now if I were to write again my likelihood function, what I will get here is I going from 1 to 90 lambda times e raised to minus lambda xi times I going from 91 till 100, and instead of this I'll just write e raised to minus 1000 lambda. Does this make sense?
Yes.
Does this make sense? All right. So next, now what we will do is we will try to solve this likelihood function. So can you all try to solve this right now? You guys do know, right, how to solve a likelihood function?
Mm.
Yeah. So can you all try to do this right now and send me pictures of your working? Are you all trying?
Yes.
Yeah. So go on. Let me know if you find any difficulty. Are you guys solving? Isha and Vanshita?
Yes.
Yes, ma'am.
Okay, good, good.
Ma'am, I've sent it to you, but it's not getting delivered.
Hello, am I audible?
Yes, ma'am.
Okay, okay, yeah. So I think I did receive you guys' pictures. Very good, Vanshita. You even checked the double derivatives. So good. Yeah. So again, yeah. So thank you very much, guys. And yeah, it seems easy, right? Or was it a bit difficult to see how the information got incorporated later on?
No, it was easy.
Easy, right?
I
So
think
let
the
me
only
just
catch is to break down the information, else it is easy.
exactly right. And that is what matters a lot because you have to tear apart the question bit by bit to get all of what's they are giving you information about and to even know. Okay. Yeah. So let me just share my screen again. Why is it paused? Okay. So I hope that's good. Okay. So the next thing that we have is a bit of a different concept, I would say, but it's just the name of the concept that is different and the parties involved will be different, but the math would remain the same. So sometimes what happens is we have policy access in place. And what do I mean by policy access? So see, if you go to an insurance company and if you insure, let's say, an accident, and what happens is only so you incur only a loss of, let's say, I would say 100 rupees. I mean, this is very unlikely case, but again, it was just a minor accident, I would say, and you only had to, just do a bit of a dressing here and there, and that's it. So, will you go to an insurance company and say that, I insured, so now you're supposed to pay me this claim amount? What will you guys do? Will you guys go to the insurance company for 100 rupees?
No, save it for a bigger claim.
Save it for?
A bigger claim that
Okay,
could be
okay.
possible
So
in the
it is
future.
not, so it's not that if you incur one accident, you will exhaust your insurance. If you incur 1,000 accidents in a year, you can claim 1,000 times. Will you still go to the insurance company to claim that 100 amount?
Oh, okay. No, still no.
Why?
Because it's a very
Because
It's too
it's a
much
very
of
small
hassle.
amount.
it's a very small amount, right? And again, the cost of going to an insurance company and then they investigating your claim amount and all those stuff might even exceed 100. So in a way, it's a net loss if you go to a company with a claim amount of 100 rupees, right? So what happens is sometimes companies say that, so remember the way we had retention limit, the reinsurer got involved in the insurance only if the claim amount exceeds capital M, right? So a similar case happens now with the insurance company. So the insurance company will say that you guys come to me only if you incur a claim amount bigger than L. Otherwise, don't come to me. So this will be the kind of thing which is known as policy excess. So what happens is you have some, if you only if you exceed a particular amount, then and then only you go to an insurance, and then the rest of the amount will be paid by the insurance company. And the bigger, so the first part of it will be incurred by the claimant itself. So let me just write this. So the concept we are studying right now is policy excess. So here what's happening is everything remains same except the fact that the reinsurer in the first case is now the insurance company, and the insurance company in the first case is now the customer of the insurance company. So let me just denote again by Y the amount. So I'm denoting by Y the amount that is incurred by the insurance company. Okay. Sorry, insurance company. So what do you guys think will be the distribution of this thing now? So now I have to write. So let's say if I say that my x is less than or equal to L and my x is greater than L, where L is my limit now. So what do you guys think will happen to the claim amount of Y in this case?
For the first, like x less than L, it will be 0.
Yeah.
And for x greater than L, will it be x?
Will it be X? What do you guys think? What do other people think? Why do you think it should be X?
Ma'am, sorry. Like I wanted to ask, if the amount is greater than L, the insurance company will pay the full amount, right? Claim amount.
No, no, no. Only the rest of it, like the insurance company
Okay,
needs
then
to
it will
pay.
be x minus L.
It will be X minus L. What do you think, Isha and Vanshita? Should it be X minus L? Isha and Vanshita, can you hear me?
Yes.
Can you please repeat what L stands for?
It is just a limit, um, like the retention limit. So what happens is, if my claim amount is less than or equal to L, then the claim amount won't be incurred by the insurance company. The customer can only approach the insurance company if the claim amount exceeds a particular limit, which is L. So this is just to avoid, the cases where people might come to insurance company, हमारा 5 रुपए का नुकसान हो गया भरपाई कर दो हमने इंश्योरेंस ले रखा है. Does not make
Yeah,
sense,
yeah,
right?
yeah. So this
So
L,
yeah.
it is set by the insurance company itself.
Yeah. It will be set by the insurance company itself. So it's like, see, they'll have different kind of policies, right? And it depends on the customer. If they really like this policy, they will take this. If they don't, they will not. So that was really a good question, because what happens in the case of reinsurance is the limit is set by the mutual agreement of the insurance company as well as the reinsurance company. But here, without taking into consideration the actual customers, the insurance company sets a limit by themselves. And then it is up to the customer, do they have to take this or not? But this is what there is.
So I think it will be. x itself in the second case, because if suppose the limit is like L, and if the yeah, so the limit is L, that is, if we say it is 5,000, so like up till 5,000 maybe the customer can do it himself, but if it is something big like maybe 7 or 10,000, then I think the insurance company should pay the entire amount. Like why will the first part of the burden fall on the customer, right?
Exactly right. So again, just to put it out there, this can be the case. Again, it is just the way you define a policy to be. But when you're looking at the policy excess, this in this particular kind of scenario, what the insurance company does is they won't pay the first L part of the claim. They will only promise you to pay the X minus L part of the claim. So in this scenario, we have a policy excess, and that is why you say excess. So everything that exceeds L, the rest of it will be paid by the insurance company. The previous part of it, the customer has to incur the loss themselves. And again,
Oh,
the
actually, ma'am, I
policy,
was saying the other way around.
yeah, I know. So the policy that you just said is that there should be only X. So even that could exist. But again, it just depends on how the insurance policy is drafted. I mean, there could be another policy where if it's less than or equal to L, then they don't pay anything. But if it's greater than L, they pay X. So that there's nothing wrong in that. But it's just that when we're looking at the policy access scenario, it implies that the insurance company is paying only the leftover part of after M, after L. So it is just a matter of how you write things and how you define your policies. So this is just like one example of where the insurance company takes place of the reinsurance company and the customer takes place of the insurance company. So if you have a look at this distribution, if you just substitute M instead of L, you get the reinsurer's distribution, right? In the cases that we have looked at yet. So yeah, it's just that. And again, what happens is basically the I mean, it's just that the premium that will be paid on such policies will also be reduced than the premium that will be paid on policies where the insurance company will be incurring all of the X, as you said. So there will be some adjustments as well. So I think it will be up to the customer to decide. And yeah, I think it's just that if you want to calculate anything else, the only thing that you need to know is how is how are the claims distributed between either the customer or the insurance company and the reinsurance company, right? So in a way, insurance company is just another customer to the reinsurance company. So that was it. And I would say these are only the concepts. So these are all of the concepts that we have to study in this chapter. And now let us try to do a sum, which will involve almost everything that we have yet studied. Are you guys ready for it?
Ma'am, can you just please define L in, like, something that
It,
we can write?
okay, so L is just a limit. That's it. It is a limit. Do you guys still have any doubts? Do you guys have any other questions? Isha,
No, ma'am. Clear.
Savri, Vanshita.
No, ma'am, clear.
Okay. Okay, so I guess we should proceed with the question. And let me check the question now. Okay, so the question I was initially planning to do, let us just do that. Okay, so the information that I have is okay. Let me just put the question in the group, and then you all can tell me the information that the question dictates one by one. Yeah. So can anyone read the question? Vanshita, can you read the question for me this time?
Yeah. Claims from a portfolio are believed to have a Pareto distribution in year 0, where alpha is equal to 6 and lambda is equal to 1000. An excess of loss reinsurance arrangement is in force with a retention limit of 500. Inflation is a constant 10% per annum. Find the distribution of the insurer's claim payments in year 1 and 2 before reinsurance, and find the percentage increase in the insurer's mean net claims payout in each year.
Okay, so now I'll want the bits of information from each one of you. Isha, can you tell me what should I write first?
So we will write that the claims, that is X, follow a Pareto alpha comma lambda distribution. So we can directly write 6 comma 1000.
Okay. Savri, can you tell me the next bit of information that I should write?
M is equals to 500, capital M.
Vanshita, can you tell me the next?
The inflation is 10% per annum.
Yeah, so should I write like INFLATION is 10%? Can you tell me a number for it, the way to denote it? Yes, Vanshita.
Inflation is denoted by K.
Yeah. So my K is
0.1.
0.1. Okay, so remember my K is inflation factor, right? So let's say if today I have a claim amount of X, then I say that if my inflation factor is K, then tomorrow my amount will be KX. So if I say you that my claim amount today was 100, and according to you, if the inflation is 10%, you are saying that my K should be 0.1. And so my claim amount will be this much, which is what, 10? Do you think this makes
No,
sense?
no.
Then what should my K be?
Actually, ma'am, to be honest, I haven't revised the inflation part. I thought I would, but I was watching the previous video lectures, so yeah.
Okay. But again, forget. I mean, you don't even need to know the inflation part for this thing. You just need to apply some logic. Forget about the math and all that we studied. You don't even need to know all of that to know this. If I say you that today I incur a claim amount of X, and if I have an inflation factor of K, then I have the claim amount as KX. So what do you think will happen? So let us say I have a claim amount of 100 today. And if there is a 10% inflation in the economy, what will be my claim amount for the next year? Can you tell me that? This is simple math, right?
110, 110.
110, right?
So
So
it
what
should
should
be
you be
1.1.
multiplying? It will be 1.1. So what
Yeah.
did you do? How did you come up with 110? You took 100
And
plus
10% of 100.
10% of 100, right? So 10% is what? 10 upon 100. So you got 110, right? And again, what you can do here is take out this 100 as common. So you can also take this 100 as common, and what you'll be left with is 1 plus 10%. So this is 100 times 1 plus 0.1. So 100 times 1.1, right? So again, my K will be what? 1.1. Does this make sense now? Does this make sense now, Anshita?
Yes, ma'am.
Okay. So now can you tell me what is the question asking of us? The first part of the question? Anyone? Isha, Savri, Vanshita?
And they're asking for the distribution of y for year 1 and 2. So one will be with without inflation and one will be with inflation.
Right? One will be without inflation and the other will be with inflation. Good. So what do you think I should do?
So it will be in the form of like the form that we write usually, right? Like for x greater than m and similar x less than equal to m and x greater than m. The claim amounts we have to write,
Yeah,
right?
yeah. So, okay. Can you dictate that?
So it will be y equal to uh, with a curly bracket for x less than equal to m. It will be x, and for x greater than m, it will be m for the first year.
Okay. Then,
Uh, like for the first year, as in, are we calculating this at the end of the first year?
why do you think it matters?
Because if because if we are doing that, then we'll have to add in the inflation amount.
Ah, no, 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 no. Don't worry about the inflation in year one.
Yeah, so it won't be there, right?
Oh, no, no, no. So we have, okay. So again, we missed a bit of information that we are taking into consideration year zero as well, right? So in year zero, there was no inflation. But in year one, there is a inflation of K,
Right.
right? So in year two, again, there will be an inflation of K, but
Yeah.
from what? From year one.
So will it be like,
So this what we have written here is basically year zero.
yeah, right.
Yeah.
So
What
for
will
year
I do next?
one, it will be the same. Uh, just for the inflation,
I think in place of X, we'll write K.
Manshita, I guess can you improve the volume or maybe be closer to the speaker? I couldn't hear you well.
Now can we?
Yeah, a bit better.
So we can write, I think we should write Kx in place of X for year one.
That's good. Yes, it will be KX. Next.
here it will be M itself.
Okay. So again, see, this isn't the actual distribution of insurance claim payments. Why? Because when I'm talking about a distribution, it has to be a proper PDF type something, right? This is just the way it is distributed, right? This is just the way the claim amounts are distributed. And if I say that my X follows Pareto 6, comma 1000, what do you guys think this Y will follow? That is my question here.
So will it be divided into parts like probability Y less than the retention limit? So probability, oh no, or do we not have to find the probability?
You guys say, I just do it.
And do we have to make use of MGF to find the distribution?
Go on. How will you use the NGF?
So, ma'am, for y, MYT will be e raised to ty, and then y will be split into x and m. So,
Yeah. And then what should I write?
Ma'am, expectation of e raised to ty.
Oh, yeah, yeah. Sorry. Yeah. So what should I be writing next?
then it will be distributed into expectation of e raised to tx plus expectation of e raised to tm.
Do you guys think this is correct? What should I be doing next?
will we have to express x as a series? It will. So, ma'am, for that, actually, will the inflation amount for year two, will it be k square or will it be 1.2?
You say, what do you think it will be? So why do you think it should be k square and why do you think it can be 1.2 as well?
I think actually it should be k square because if it goes by the logic of 1.2, so for 1.2 I just directly added 0.1 to it.
Can you do that?
I don't think so because if we go by that rate, then the inflation will just go on increasing like crazy.
See, that is one reason, right? I mean, a question, I mean, this is fictitious, right? This is not reality. So they can give you something like that, but again, it does not make sense, as you rightly said. So if you read the question properly, what it says is that the inflation is constant 10% per annum, right? So if in year zero, you have, let's say the claim
Yeah,
amount is
so
X.
like for year zero, we are taking the base as k and then we multiply it into uh like basically eh, the base is 1 and then we multiply it. Like, how should I explain? I got it, but like in the next year, the base will be kx and not k.
Yeah, right. Because per annum, so for year two, the previous year is 1. So the claim amount is kx, and now it will be inflated by a factor of k. So you get k square x. Does this make sense to everyone?
Yes.
Okay. So what should be happening next? Again, someone was talking about writing a series of x's
Yeah.
and yeah.
So, if we try to write x, the uh, basically the payments of x less than the retention limit, we can write it in a series like x plus kx plus k square x and so on. Or do we have to find it only for the first 2 years?
You say so. What are you doing here by writing such a thing?
Forming a
So x.
geometric series.
Huh? Building a geometric series. Okay, okay. That's a really cool idea, I would say. But again, does this make sense? So this X is the claim amount incurred for the year zero, only one claim amount. Then this KX is another claim amount incurred for the year one, and then you're adding something for the year two. But the question asks us to find the distribution of insurers' claim payments for year one and two. So for year one and year two, because we know that in year zero, x follows Pareto's x comma 1000, right? So now, if I denote this by x, let me denote this by x1 and let me denote this by x2. So these are my claims in year zero, year one, and year two, right? So now I want to know what is the distribution of my x1 and what is the distribution of my x2. This is what I want to know. So is this helping me by adding year 0, year 1 and year 2 together?
No.
No, right? Because I want to look at them separately.
Yeah.
So yeah, this, I mean, I'm not going to cut anything that we write on the board. So this is, of course, not an easy
So
question, I would say.
distribution as in they just want the parameters.
Yeah, parameters and the distribution itself, like, right, like will it be Pareto or will it change to Weibull or will it change to something else or something else? We don't
Okay,
know.
got it, got it.
Yeah. So I think the idea when Savri said that we should try with MGF, Savri, can I know why did you think that we should use MGF?
Ma'am, because usually when we are transforming a variable, we use MGF to find its distribution.
Yeah, we use MGF to find the
That
distribution. And why do you think
and
we
there's
use
that
MGF?
expectation of
Okay, okay. Answer my question first, and then I'll listen to what you have to ask. Okay. Why do you think we use NGF to find out the distribution, and why not anything else?
It becomes
Any?
easier because we can express, like for in this case, we can express y in terms of x and we know the distribution of x. So by
Yeah.
using the formula, so that it becomes
Um,
easier.
it becomes easier. So you do this only for it to be easy. Okay. What does Isha and Vanshita think about this? Do you guys
we
agree
don't
with Savir?
have we don't have MGF for Pareto distribution like in the table. So like what do we compare it? Like for comparing, we will have to compare the parameters to describe what distribution it has.
Yeah. So again, that is actually a very valid, I would say, inference. But again, coming to our actual question that I posed was, why do we use MGF? Leave apart that we are looking at the Pareto right now. She said that generally we look at MGF if we are to figure out the distributions or something. So why do you think we look at MGF? This has to do with a very unique property that only MGF possesses.
So we can like find out the moment. So like we can find out expected value of x and then maybe expected value of x square, and then we can compare the two and find out lambda and alpha.
Not really, I would say. I mean, that is a property of MGF, but that is not why we use MGF to figure out the distribution.
Ma'am, are you talking about the uniqueness property of NGS?
Yes, I am. I am looking for that answer. I mean, I did explain that to you guys, right? When we talked about the MGF,
Yes, ma'am.
that MGF is unique for each distribution. So, because if we get some answer for the MGF, and if it looks alike to a distribution's MGF, then we know that, yeah, because of the uniqueness property, I can say that this follows some blah, blah, blah distribution because it looks like it's MGF, right?
Yes,
So,
ma'am.
yeah, go on. Now you had something to ask. And Vanshita has a concern that we don't
Yeah, ma'am.
have,
Just that
Pareto's MGF in the table booklet. That's sad. So what can I do now?
ma'am, I just wanted to say that the expectation of e raised to ty can't be expressed as that sum of two expectations. It
Yeah,
can
why do
be
you
expressed
think?
in the form of integration. Ma'am, because we can't actually express directly say that y is summation of x plus y. We can do it in the form of integration, but not exactly the sum of those two.
And how do you think we will do it in terms of integration?
For integration, it will be integration 0 to m e raised to tx f of x dx plus integration m to infinity e raised to tm f of x dx.
Do you see, Savri, what's happening here? So when we wrote that this is expectation of e raised to tx, we didn't take this information into account, right? That my expectation is not from 0 till infinity. It only has to be from 0 to m, because that is the only case when I pay the amount x, and for the other cases, I pay the amount m. So if you just write expectation of e raised to tx, what it means is So this is basically integration of 0 till infinity e raised to tx f of x dx. And this is not what we are looking at, right? So this itself is wrong. So this is how you can rewrite this. Okay. So what can I do next?
Can we substitute the values?
Yes. Do you want me to do that? What should I write?
So it will be integral 0 to 500 e raised to tx into, so f of x, should we write the Pareto formula?
As you say.
Oh, I don't know if it will help. So
Why do you think it won't help?
because I don't know what to do ahead, like how to go ahead with it. Like
Can you
I don't
consult
know
your...
what we will have to do after substituting the formula.
Okay. So can you think of something else that we should do or we can do? Yes.
Ma'am, actually, I just wanted to ask, like I said, we can use MGF, but as Anchita pointed out that we don't have MGF in our table book of Pareto. So then how we will
Yeah,
be compare it to?
exactly right. So we don't have the MGF formula for Pareto in the table booklet. Okay, so if this boils down to Pareto, which we think, or I mean, it may or may not. So we have a few that, if it has to be Pareto, then the MGF, we don't have anything to compare it with. Okay, so now we can't probably use MGF. So, okay, so we discard that idea. What should we do next if we can't
Should
use
we try
MGF?
to use the CDF?
As you say. So let me just finish this. Can't use MGF and this is sad. So, okay, fine. Okay, what should I do? How will I use the CDF?
So now basically again we have a probability x less than 500
Okay,
is equal to 1 minus lambda. So lambda over here was,
1000.
yeah, 1000 uh, upon 1000 plus 500 raised to alpha. Uh,
So, what should I do next?
so next we can write it for m.
Go on.
Can you show the previous page?
The CDS that Isha told was for year zero, right?
Yeah, can you say that again? What was for year one?
Sorry, I didn't get you.
Um, Vanshita, I guess your voice wasn't clear. Can you be a bit nearer to your microphone?
Yeah, my mic is near my mouth, but I don't know, there's some problem with the earphone. I
Okay.
asked that the CDS that Isha told was for year zero, right?
Yes. Yeah, because what I wrote was X, right? She dictated me X, and I know that I'm denoting my year zero thingy as X. And if I have year one's claim amount, I'm denoting them as X1 and X2. And remember, we have to figure out the distribution of insurance claim payments for year one and year two. We already know that X follows P, but it was 6,000. Think, what can we do? What should we do?
Ma'am, so for year two, it will be something like probability kx less than 500.
Okay, are you talking about year one or year two?
Year one.
Year one, right? Okay.
Probability
So this is
kx
for year, yeah,
less than 500
yeah.
is equal to the same thing as above. But here,
Right.
like, no, so here maybe we can rewrite it as probability x less than 500 by k.
Good, because we don't know the distribution of kx yet,
Yeah,
right?
yeah.
That is
So
what we have to figure out.
equal to the same thing as above, just in place of 500, we'll write 500 by k. And we know k,
Okay.
so that will be,
So let's just keep it in terms of k for now, because if we do it for k, we would have done it for k square as well, right? We can just
yeah,
replace k
okay.
by k square. So we keep it k. Does that
Yeah,
sound good?
yeah.
Okay. So what can I do next?
So similarly, write it for year two.
Okay, so forget about year two. Let us just first derive the distribution of year one. What is the distribution of year one? And then we'll have a look at the distribution of year two. First, only have a look at year one's distribution. So I've written what Isha just said. What information do you get from this about the distribution of year one claims? And again, you know, this only incorporates the claim amounts which are less than 500. So you
So
have
if we
ignored.
have to keep the 500 constant, then like basically we,
Multiply and divide by k.
yeah, k. So it will become 1 minus 1000 uh, k upon 1000 k plus 500. So will our new lambda be 1000 k?
Yes, it can be, right?
Yes.
So you claim that my lambda 1, so it implies that my lambda 1 should be 1000 times k.
Yes, right.
But again, I mean, I have a question in what we just did. You have only used the fact that your kx will be less than 500. What about the other half of it? What if this lambda 1 does not satisfy? So should we check for those as well?
I didn't understand your question.
Okay, so what if I figure out that the probability that my kx will be more than 500 I mean, you have only taken into account the claim amounts which are less than 500, right? To say that your lambda 1 is 1000K, but you also have to take into account the claim amounts which are greater than 500. So also the case where probability that my Kx will be greater than 500. For this thing as well, whatever answer you will get, it should satisfy the same thing. And only if it satisfies for this case as well, then only you can say that yes, lambda 1 is 1000K in fact.
Yeah,
Do
so
you
we can,
agree with?
yeah, so we can do it for that also. So it will be probability uh, again x greater than 500 by k
Yes.
is equal to, now
But
it will be
it is
1
given
minus.
that before reinsurance, right? So before reinsurance means that the claim amount does not exceed the retention limit.
Where have I mentioned that we're looking at before insurance case?
It's mentioned in the question.
It's mentioned in the question before insurance. Very
Yeah,
well,
so
very
it
well.
says, yeah, find the distribution for the insurance claim payments in year 1 and 2 before reinsurance.
Very good. So we don't care about this stuff, right? So we only have to look at before insurance.
Ma'am, but if there's no reinsurance, there will be no retention limit considered as well.
Yes. Then what will you do? So now what can we do?
Just put X instead of 500.
Just put X instead of 500. Okay.
No, no, not x, just some constant like m, because the constant value won't affect our equation anyway, so it is still valid, I think, for comparison.
Okay, so again, if you take any constant, I mean, even if you don't say that it is 500 specifically, you are in a way assuming that there is reinsurance, right? Even if you take a constant.
Oh, right.
So what should we do?
It should be a variable.
Yes. So I replace 500, a constant, with a variable small x. Okay. So again, this is not what we will be doing. Let's see. So can you all again dictate what should I be doing? So this is for year 0. Now what will happen for year 1? Right? And now what do you see?
So we can infer the same results as before, right? We just remove the 500 value.
Right? So now my lambda 1 is just again k times 1000.
Yes.
And what I can say, so now if my lambda 1 is k times 1000, what is my alpha 1?
It's the same.
6.
Is
Same.
the same, right? So now what will be the distribution for kx?
It would be Pareto 6 comma K into 1000, which is 110.
Right? So my k is what? 1.1. So it will just be 1100. Okay. So this is done for year 1. And now if I have to do it for year 2, what will it be?
Everywhere instead of k, it will be k square.
Right? Everywhere instead of k to be k square. So we can leave all of these steps, directly jump here, right? Lambda 1 will be what? It will be k square times 1000. So my lambda 2 will be k square times 1000. And what do you think my alpha 2 will be?
Yes.
It won't change.
Same, right? It won't change. Perfect. So what will be my k square x following? So this is my x2 and this was my x1.
1210, right?
Yes. Perfect. That is it. We solved this question. Voila. So again, this is how you can actually, solve this question. And again, there is another method which you can use. So you can use the fact that any PDF sums up to 1. So here you only took into consideration these claims, right? Kx is less than x. So basically you took into consideration a particular CDF, right? And again, we can't necessarily um, say that, this is wrong because we know that, the CDF that we get at the end for the KX1 is also looking like Pareto, but just with the lambda value also inflated by a factor of K, right? And again, for the X2, the same kind of a thing happens. So I guess I would say that's it for today. And we'll do the second part of the question in the next lecture. Do you guys have any other doubts? Anyone? Any
No,
doubts
ma'am,
with
clear.
this question or anything that we did today? So I want you all to, try the second question by yourself and see if you can get anywhere. You can WhatsApp me, no worries, and I'll guide you through the answer. Does that sound good? Am I audible? Hello.
Yes, ma'am.
Yes,
Yeah,
ma'am. Okay.
okay. Makes sense. Okay. So again, we just have to figure out the mean net claim amount for the insurance company for the year 1 as well as year 2, and then for the year 0 as well, I would say. And then you just have to look at the percentage increase, right? So again, without doing any calculations, what can you say about this percentage increase in the insurer's mean net claim payment? What can you say without doing any calculations? It has to do something with what we studied here. Yeah. What do you think will happen or is likely to happen?
And it will apparently increase by less than k, because as from the parameters we can see that the lambda has changed by k, but the alpha is same. So if we take the mean, then it will be less than k. Like the increase will be less than k.
So I do agree with the fact that you say that, the mean claim amount will increase by less than K every year. But I don't agree where you explained the reason behind it being that the alpha stays constant and lambda changes with the K. So you can never really say if that's the reason, right? Because I mean, alpha changes with K, but then how much do you think, sorry, lambda changes with K, but then how much do you think alpha should be changing for it to, increase or decrease by a less than K or greater than K? You can't really say that, right? I mean, you have to do a whole set of another calculations for that. And the reason behind it is again the fact that retention limit does not change with the inflation factor. So it has got nothing to do with alpha, I would say, because just look at the derivation that we just did, right? If we say that my inflation limit also changes with the k, then this x wouldn't be x anymore, right? It would become kx, and then this k and that k would cancel. So my answer would be similar to this. So my instead of my alpha getting multiplied by k, what will happen instead is that my lambda won't get multiplied by k. It will stay constant, right? So that is the reason. Nothing is happening to alpha here, and nothing that can happen to alpha can dictate something else. But yeah, again, I think the actual reason for that happening is that lambda 1 gets multiplied by k. And if this doesn't happen, which will be only if we have a k here, which will mean that instead of x, we have a kx, which will mean instead of this x, we have a kx here. Does this make sense? Hello. Does it make sense? Any doubts?
No doubt, ma'am.
Okay. I would say that is all for today. Enjoy the rest of your weekend and do
And do we have
revise.
class tomorrow?
Yes, we'll continue with the question, the next part of the question.
6:30 to 8:30, right?
Yes,
Okay.
Ma'am, can you keep it 5 to 7 if it is okay with everyone?
it's not okay with me.
Okay, no problem. Sorry.
I have to have my dinner.
Sorry, ma'am. I thought it will be. Sorry.
No, so it's like I do my dinner before the sun sets. So yeah, I have to do it by 6.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Have a great weekend. I'll update the lecture recording as well as the flip chart. So, and yeah, I would highly encourage for you to please revise as and when we complete things in the classroom. Okay, so I'll end the meeting.